A point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as omega is equal to a square root of v, where a is equal to positive constant at the initial moment of the velocity of the point is equal to v naught. At what distance will it traverse before it stops? In the second part of the question, what time will it take to cover the distance? Solution: from the data given, deceleration minus w. Here negative sign represents the deceleration or retardation of the particle, that is equal to a under root of v. We can write deceleration as dv by dt, where the rate of change of velocity, and a under root of v. Here this expression containing only velocity and time, two parameters are there, but in the first part of the question we need to calculate the distance. Hence I have to modify this expression in terms of distance and time function. Hence I can write slightly, I will modify this dv by ds and into ds by dt, that is equal to a under root of v. We know that ds by dt, rate of change of displacement, is nothing but velocity, so it can be written minus v into dv by ds, that equal to a under root of v. I will bring this root v this side, hence the relation under root v into dv is equal to a into ds. So I need to calculate the distance before it stops on either side, integrate on either sides, integration of root v into dv, that is equal to a. I'm not doing integration because that is a constant. Integration of 1 into ds. So we know integration of under root v gives rise minus v power 1 by 2 plus 1 by 2 divided by 1 by 2 plus 1 by 2, that is equal to a into s. And we know the limitations. Velocity varies from, here it is given the initial velocity v, the final velocity 0 as it comes to rest. So v is equal to v is equal to 0, and the displacement, the limitations, s is equal to 0 to s. So when you substitute the limitations, we get the s is equal to 2 by 3a v naught into 3 by 2. I am continuing the second part of the question on the next sheet. Second part of the question is asking to calculate the time before come to rest given minus omega, where omega is representing the deceleration of the object, that is equal to a under root of v. We know deceleration omega is equal to dv by dt, that is equal to a under root of v. Here velocity and the times are variables, so I am separating the velocity terms on left side and time terms on the right side. Minus 1 by root of v into dv, that is equal to a into dt, minus v power minus 1 by 2 into dv, that is equal to a into dt, integrating on either sides, both sides, integration of v power 1 minus 1 by 2 into dv, that is equal to a integration of 1 into dt. Let's say at the initial position time is equal to 0. After t seconds the object comes to rest. Initially the velocity is 0 at the moment when it, sorry, here the initial velocity v, when it comes to rest, the final velocity will be 0. We know integration of v power minus 1 by 2, v power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1, that is equal to a into t. So here minus 1 by 2 and minus 1 by 2, sorry, 1 minus 1 by 2 plus 1 by 2, here also plus 1 by 2, that is equal to a into t, that gives rise minus 2v 1 by 2 is equal to a into t, and t is equal to, time will be never negative, hence I am taking the modulus of the time, hence 2 root v divided by a. This is your final answer.